Well guys, the time has come to do another modification to the mighty Wrong Foo. And what I'm going to do is take the 2-axis DRO I have off of this thing along with this Z-axis, and I'm going to install a real 3-axis DRO. People are probably wondering, why are you not going to use this anymore? Well, what I've decided to do here is to incorporate a Z-axis that will read the quill as well as the position of where it is on this RAM, on this column. And the way I'm going to do that is I'm going to get a scale that goes from this, well, let me get on the other side here. Goes from this bracket through the housing, through this plate, and up to this bracket. Okay? And then I'm going to attach the reader to the quill. And what that will do is, when I raise the head, the quill will go with it, and that will read Z. And when I lower the quill inside, it will pull the reader down. Now, the reason I'm doing this is because I want to put this DRO, which is a 2-axis DRO, on this lathe. And you may recall that before I moved, I installed this encoder on the X-axis, which works great, but I'm kind of getting tired of swapping connectors back and forth between the mill and the lathe. So what I'm going to do is eventually I'm going to take this encoder right here and cut it down and mount it right here. I was going to mount it over here like I see a lot of people do, but with this lathe here, this edge will never get to this point here. It'll, just don't get that close. The spindle sticks out farther than that. So if I put it on this side of the compound or the cross slide, I will lose, the space in between the tailstock and the cross slide. But if I put it over here, I won't lose any space. So that's the plan for this, and that will happen subsequent to me taking apart the mighty Wrong Foo. So anyways, the one thing that I have to do here, well, there's a couple things actually. First thing I have to do is I have to drill a hole down through here to allow the encoder to come up through. And then I have to build a couple little attachment blocks right here. Now, one of the things that caused me to want to do this is the fact that there are companies on Amazon in China that will sell you 3-axis DROs for a little over $300, which is like silly cheap. And they got 5-micron scales on them, which is plenty accurate enough for what you're going to be doing with the mini mill like this. So the deal was with the one that I bought is they will cut the scales to whatever size you want. So what I did is I measured my X and Y and Z requirements, and I sent that to them, and they are sending me scales that are already cut to the lengths that I need. I hope they're going to be right. I might end up cutting them myself if not. I have cut these scales before. It's you got to kind of be careful. What I do is I will cut the aluminum extrusions, like for this one. This one used to be about 4 feet long. I cut the aluminum extrusions, and then use a Dremel tool with a carbide cutter wheel to cut the glass. And you can do that. I mean, you got to be careful, and typically I cut my encoders as long as I can get them, so that if I do kind of chew up the end of it a little, it's not going to be a big deal. So anyways, what I have here is my copious notes. Here are the scale diagrams, and this is a top-down view of what I have to cut in that plate. This is another little drawing that I made to show where things have to go. And then you can see on this diagram where that encoder scale is actually going to be. So what I will do is I will attach a very rigid bar to the quill so that the encoder reader is encased within the head of the thing. And since the quill only has to move up and down, it's like 5.5 inches on my machine, that reader and encoder will always be inside of the head, so I don't have to worry about chips and stuff getting in there. You know, obviously when I raise the head all the way to the top, there'll be a little bit exposed on the bottom and vice versa, but the encoder that I bought has lip seals on it, so as long as we're not really stupid with the air gun, it shouldn't ever be a problem. And I'll route the cable up and out the back for the Z-axis. So I'm going to get started here. I'm not going to show too much of this as far as me drilling holes in the machine and stuff like that, because everybody's machine is a little different. You know, I realize nobody has big plates on the top like I do, but all the RF30s have these holes right here, and typically it's for the light bulb. So that's where the encoder is going to come out the bottom of my casting. Alright, so let's get started here. Okay, so you're probably wondering how I located this hole. This column is the reference for everything. So what I did is underneath here, I measured how far away from the column the edge of the hole was. Not too hard to do. Then what I did is I came up here, I put a center finder on this column, and I used the center of the spindle as the other end. So now I know that this ruler is in line on the center line of the machine here. Then what I did is I dropped another square down here, and the edge of that ruler is in the center of the hole. Okay, I just used a magnetic V-block there to hold everything up. So now you can see that I have a hole right down through the center of this machine. You can see my hand down there. The encoder is going to come up through this hole and attach to this bracket. It's also on the other end going to attach to this bracket. Now this will be at a table reference. In other words, the table is not going to change in relation to this column, the Z height of it anyways. So what I'm going to do now is I'm going to mount a vertical post on the back of this bracket. Let's see if I can show you this better. Okay, right there. And that is going to go up through the hole, and somewhere about right in here at this height I'm going to mount the encoder reader head. So, you know, that's how I'm going to get the Z-axis to read both the quill and the column height at the same time. Alright, today is DRO day, and we get our DRO scales custom cut to my specified lengths, direct from Hong Kong. And I gotta say, they arrived here in record time. So let's see what we got. Okay, it looks like there's two of them in here. I'm gonna have to measure these and find out which ones are which, but yeah, nice stuff. Sweet. All right. These are nice. Looks like they have a little shipping stuff on them here. We'll have to remove that. These cables are mega flexible. All right. All right, I'm betting this is the Z-axis, so I'm gonna test fit that thing in the head, and we also have the DRO head. Let's put these scales in a safe place here. Got another one here. So that's 3-axis. Okay, so the one complaint I've heard with this thing is that this manual is ridiculously stupid. Yeah, it's kind of it's going to require some study there. Got an arm. Don't know what that's all about. Collet rack maybe? Here's the readout itself. Holders. Oop, there's something else in there. Swivel base thing. Yeah, this thing's light as a feather. think they intend to have you leave this on here, but I'm going to have a look at it anyways. So yeah, this is pretty nice. Reasonable push buttons. All right, Chinese DRO. So what I'm going to do now is make sure those scales are the right length that I specified, and see if they're going to fit on the mill here. So hang on. Well, these guys, they didn't exactly cut them right. Fortunately, they're all a little longer than they have to be, so I'll be able to do some stuff here. I have to put this up from this side. But yeah, you know, what they have you do is specify a travel length, and you know, basically most people specify these things as, you know, total overall length. So guy told me add 138 millimeters to the travel length and you'll get the overall length, but that wasn't exactly right. So this one's about 1 inch too long, but it's not a big deal. So that's going to go like that. I can put a block on the top there for it. So, all right, well, I might have to trim the X, because that's a little too long. But longer is better than shorter. Actually, this one's probably close enough that it'd be okay. And the Y is totally non-critical as far as the length goes, so these will all work with what I have in mind here. Yeah. All right, so we're going to get to work mounting these scales. That's the Y. X is over there. Tell you what I'm going to do here before we go any further. Y. Z. And X. All right. I think the first order of business is to take off my existing DRO scales. Okay, I got one axis installed here, and that had to do a little bracketizing, but as you can see, it is working. Okay, so we're going to have to do the X now. Okay, well, I got the X and the Y mounted here, and I'm just doing some checks. So far, the Y looks perfect. The X I'm not so sure about yet. Kind of like over long travel distances, I'm getting a couple of tenths error. So I got to look at the specs in this book and see if I can decipher them. But you know, I got them mounted. There's the Y. Reader head's over here. And the X is on the back. See that? So tomorrow I'm going to do the Z. Okay, well, I finished verifying that my X and Y scales are correct. I was having a problem with the X scale, and it turns out that on these particular scales there's a gap right between the reader head and the scale body itself that is really critical. So I had to kind of goof with that a little. I guess I kind of got lucky on the Y scale because that one just worked out. It was perfectly accurate. The way these things come is like this. They've got this red shipping spacer in here, and when you take this out of there, you got to set the gap so that it's 1 millimeter away from the body of the scale, and there can't be any tilt to it. It's got to be like perfectly flat. It's very critical. My Heidenhain scales here, these things work. I mean, you just throw them on there and they work. You really don't have to go crazy setting them up. But these scales here, they're very critical. Okay, I kind of get this mocked up the way it's going to sit in the machine here, and kind of see that I've got some brackets here. These brackets came with it, so I'm going to have to do a little you know, machining with them, but that's basically what you got here. So the next thing I'm going to do here, because these are pretty much right up against the backs of my holes, at this point. So what I'm going to do is I'm going to trim this down on each side here, and then I'm going to drill some holes back here and tap them in and make sure everything's squared and centered, and then I can hook the scale to it. And then up here I'm going to do a similar thing. So yeah, a lot of layout here and some cutting, but we'll get it. But that's basically how it's going to work. And you know, here's where the cable's going to come out up the top here and go back to the display. And then what I did is I got this piece here, which is what usually is the height limiter, and I'm going to mount this thing backwards like this, and then there'll be a piece of metal on here that'll go up inside the head and connect up to the encoder reader head. Okay, so here's how we line up the bracket. I got my vise trimmed in, and I put some packing in there and a block and pull this up to it. Now I know this surface is square to the table, and I'm going to have to verify that this is parallel to the table, but it should be because I made these pretty accurately years ago. What I'm going to do is I'm going to put 2 screws in here, maybe 3, and then the encoder will come down. I'll put a hole in this, and we'll bolt the encoder to that. Up top we still have to make the bracket, but I had to take it apart because I had to use a milling machine. So it's a process here, but we'll get it going. It's you know, the X and the Y were easy, and I'm actually using that right now. The Z is a lot of fabrication. Fortunately, they supplied a lot of these kind of brackets, so I'm able to utilize them to make the appropriate attachment points here. Okay, so here's what I've done. I've got this here piece of ground stock, which I'm sure is very flat, clamped to the rack on the spindle, on the quill. And then what I did is I took a very accurate square and I clamped it to that so that it was just tangent to the side of the column. Then what I did is I took that measurement of the column diameter and divided it by 2, and I took a machinist square and I blued it up and I put a line right there. So now when I take this square and hold it up against this square, that line should be right on the center line of the quill. How can I show this to you here? There's too much stuff in the way here, but take this, put this on my square, and that line that I scribed on there should be right on the center line of the quill. So what I'm going to do is scribe that line on there. Now, you know, this is a little unnecessary because I will have an adjustment slot here, but I want to get this bracket on the center line as close as I possibly can. Okay, so I got this bar clamped onto the quill flat on the rack, and I've got a dial indicator on the column, and it's touching this bar. So there is some slop in the quill. You can see there's 150 thousandths way out here on this thing. I mean, the quill's hardly moving at all, but what I'm going to do is set this to 75 and lock it. So now the quill is locked midway on the in its rotation. What it is there's a key here on the left side of this quill that prevents it from rotating in the head. So what I've done by doing this at 75 thousandths is put that keyway right in the center. My assumption is, and this is a big assumption, is that when they machine this head, they put that keyway perpendicular to this thing. You know, if it is, it is. If it isn't, it isn't. I mean, it's probably going to be within the adjustment range of my brackets. So that's what I'm doing here now. Now what I'm going to do is I'm going to take this machinist square and I've blued up the column here. Actually, now what I'm going to do is I'm going to take this and I'm going to clamp it to this piece of tool steel here and put it tangent to the head. And what that's going to do is give me a reference back here to the edge of the column. Okay, so that's tangent now. Eyeballing it right down the length of this rule here. And that's tangent to it. Right here. This. Now, what I'm going to do here is, in a couple places, I'm going to get a tangent line here on this quill. One here and maybe one down here. And then I'll be able to draw a straight line down to this bracket here. And I'll know that this is the center of the spindle. Okay, we made our measurements. One was right there, and one was right there. We continued this line down, and we found the exact center of the column. Can't see the mark, but it's right there. So now I know that if I center that bracket on this line, that it will be right in line between the spindle and the column. Well, that scale's installed and lined up, and let me tell you, it was a hell of a lot of work. A lot of calculating, a lot of measuring, but it's in there. And you can see the reader head here is, I got it lower than it ever will be, because what I'm going to do is connect it. And I ended up turning this thing around so it was sticking back farther. But you can see if I go up and then over, I can connect to that. And this part of the scale will never be used, so I'm really not worried about getting crap in here. All the stuff that will be getting used is up inside of there. Alright, the Wrong Foo is making itself here. Just cutting a piece here that will become the vertical part of the encoder drive there. So this will probably be the last piece I have to make, and we'll just be into some alignment. Alright, here we go. This is working good. So we got regular Z-axis. And we got this bad boy. Okay, we got some cables to mess with. Got to put this whole thing back together again, but the plan worked. Man, I'm telling you, I think I used every tool in the shop here, but I'm happy that it worked out good. So what else can I say? I got to mount this DRO readout. I got to route these cables. I got to fish a drill bit out of the base of my my milling machine because something fell down in there. And then I got to clean up this disaster area. But yeah, I'm really happy. And you can see that, you know, even when the quill is all the way down, the reader head is still up inside of the machine. Alright, I used the new DRO to cut the scale for the Lathe DRO. This one used to be on my milling machine, and she works. There you go. So we'll attach this to the lathe now, and we'll have a 2-axis DRO on the lathe and a 3-axis DRO on the mill. Okay, here's a little tip if you ever decide to put a DRO on your lathe. The way this lathe is set up, I needed a 1/4-inch spacer between the cross slide and where I'm going to attach the reader head. That puts both of these on the same plane. So what I did was I cut out a piece of 1/4-inch bar stock to space it out, and I put it on the mill, and I drilled tap holes in the aluminum block. Then I spaced it off the bottom of the carriage with just this ruler. It happens to be 25 thousandths thick, which you know, I needed a little gap in there. Then what I did is I used this aluminum block as a guide to drill in with a tap drill into the side of the casting. Then what I did is I drilled the aluminum block for a clearance hole, and now I'm using that as a tap guide to tap these holes. I got this one tapped already. I'm on this one. As soon as that's done, I'll be able to mount the reader, the encoder, on this bar, and it will be permanently mounted there. Then what I'm going to have to do is take the reader and drill a couple of holes down here to get that to track, and you know, set the gap and all that accordingly. So just a little tip, you know, use a tapping block to guarantee that you're going in straight. You would hate to break a tap off in your casting. Okay, we got the DRO all wired up, got all the cables routed, everything looks good. Got a light back on it. I put one on. 2 was a little too bright, so got one 10-watt LED that I can, you know, point anywhere I need it to be. The DRO tracks the head and the quill. Can also see I got the Lathe DRO hooked up. Got the X and the Z. So we're all digitized here at the Cuppa Joe Studios now. I'm really happy with the way the DRO turned out. It was kind of a lot of measuring. Pretty good project to get the scale through the head of the mill. But I think it's going to work out good. So thanks for watching.